In this video, we're going to learn about factoring completely. What we'll see is that sometimes there's an extra term that needs to be factored out. Before we get to that, though, let's review what we've done. Here we have a quadratic trinomial, and we need to factor it. So we're trying to break it down into two factors like these. We know that r times r is r squared, and there are several different combinations of numbers that multiply to make 90. Now, when we combine our like terms, when we multiply, we need to end up with a sum of -1. All right, so let's make a diamond problem to organize our thinking here. We want two numbers that multiply to make -90 that have a sum of -1. Okay, we're thinking 9 times 10 because these have a difference of 1. And let's see, the sum is negative, so the larger number will be negative. 9 times -10 does equal -90, and they do have a sum of -1. So we have 9 and -10, which means our factors are r plus 9 times r minus 10. Notice on this trinomial, the coefficient of the squared term is 1. Now in number 2, this time we have a coefficient that's not equal to 1. This will work out a little bit differently. Same thing though, we're wondering if we can break it down into the product of two binomials. All right, when we have a coefficient greater than 1 in front of the squared term, this is where we can multiply that coefficient by the constant term. And we're looking for two numbers that multiply to make 24 that have a sum of -11. All right, in this case, we need a negative times a negative to get a positive because they have a negative sum. So let's go with -8 times -3. So let's have a product of 24 and a sum of -11. Now, since this polynomial did not have a leading coefficient of 1, we need to go to the box. These wing numbers in this situation do not tell us our factors. All right, let's start by filling in the box. The top left corner will be 6m squared. The bottom right will be 4. Now these tell us the other two boxes, -8m and -3m. All right, to multiply to make 6m squared, we actually could do that with 1m times 6m or 2m times 3m. Now in this case, the 6m and 1m won't work because the 6 we can't easily multiply to turn it into a 3, and we can't turn it into a -8 either. So instead, let's use 3m times 2m. Notice this 3m lines up with the -3m, and this 2m lines up with the -8m. All right, 3m times -1 equals -3m, and 2m times -4 equals -8m. Let's double check the corner here. -4 times -1 equals +4. Now we know our factors. So we have 2m minus 1 times 3m minus 4. Now we could multiply these out and we would get the same answer we got here. All right, moving on to factoring completely. In this example, it highlights something we should always check before we start factoring a trinomial. We should always look to see if there's a common factor to all the terms. And in this case, there is. We can divide each of these terms by 3. And we'll do that first before we do any diamond problems or anything like that. So I'm going to divide out a 3, divide out a 3, divide out a 3. And when we do that, see the 3 comes up front, and we're dividing each of these terms by 3. So that's x squared plus 6x plus 8. Now, the 3 is still a factor, so we need to keep it there. But now we're also going to look to see if we can still factor the x squared plus 6x plus 8. So we're wondering, do we have two numbers that multiply to make 8 that add up to 6? Well, 4 times 2 works because 4 times 2 is 8 and 4 plus 2 is 6. So we have our factors here. 3 is a factor, x plus 4 is a factor, and x plus 2 is a factor. So this expression here equals the original one. Let's take a look at number 4. Now, before we start factoring, we are always going to look for common terms, a common term that we can divide out of each term. In this case, we can't divide everything by 4 because 10 and 6 are not divisible by 4, but all three terms are divisible by 2. So let's go ahead and divide out that common factor. So I'm going to divide each term by 2. So we're dividing out of 2, and that goes out front. And we're left with 2k squared plus 5k minus 3. We divided each term by 2. Now we need to check to see if this trinomial is also factorable. Let's check. So we have a coefficient greater than 1, so we need to multiply that coefficient by the constant term. 2 times negative 3 is negative 6. We put our 5 down here. Let's see, we need a negative product and a positive sum. So if we do 6 times 1, that's positive 6. The sum is positive. Let's make the smaller number negative here. Now we have a product of negative 6 and a sum of positive 5. Now these wing numbers do not tell us our factors because we have that coefficient greater than 1. So let's go to our box. We'll fill in the top left corner with our squared term, 2k squared. We'll fill in the bottom right with our constant term. And these wing numbers tell us the missing boxes or empty boxes. All right, to get 2k squared, it'll be 2k times k. Now let's line up the 2k with the 6k. 2k times k is 2k squared. 2k times 3 equals 6k. And k times negative 1 equals negative 1k. And 3 times negative 1 does equal negative 3. So we now have our factors. Let's not forget about the 2, though. So we have 2 times 2k minus 1 times k plus 3. Now, there's other types of situations where when we're factoring, we need to pull out a common factor. So for instance, 90n plus 40, there's no square term, but we can still factor out a 10 because both of these terms are divisible by 10. So if we are asked to factor, or if we need to factor 90n plus 40, that will equal 10 times, well, 90n divided by 10 is 9n, and 40 divided by 10 is 4. And we cannot factor anything here, so we're done factoring there. Now here we have a fourth degree polynomial. Let's take a look, see if there are any common factors that we can factor out of both of these terms. Let's see, we can divide both of the numbers by 4, because 20 is divisible by 4, and so is 16. And we can also divide out n cubed from both of them. All right, so we're going to factor out a 4n cubed. Now, when we divide 20n to the fourth power by 4n cubed, 20 divided by 4 is 5. N to the fourth power divided by n to the third power is n. 16 divided by 4 is 4, and n to the third divided by n to the third is just 1. Those cancel each other out. All right, once again, here we have a binomial. Let's first check to see if we can factor out a common factor. In this case, they're both divisible by 3. So let's go ahead and do that. 3p squared divided by 3 is equal to p squared, and 27 divided by 3 is equal to 9. Now, before we stop, we always need to ask ourselves if we can continue factoring. Let's check. Now remember, p squared minus 9 is the same as p squared plus 0p minus 9. Let's check to see if we can find a pair of numbers that have a product of negative 9 and a sum of 0. Well, sure enough, 3 times negative 3 equals negative 9, and they have a sum of 0. So this was a difference of 2 squares. So we have the 3, and then we have p plus 3 times p minus 3. Now we have factored completely. When we look for common factors in number 8, we notice that each term is divisible by 2. So before we do anything else, let's go ahead and factor out that 2. 8a squared divided by 2 equals 4a squared. 10a divided by 2 equals 5a. 8 divided by 2 equals 4. Now we're wondering if this polynomial is also factorable, and we can continue factoring. There's a leading coefficient greater than 1, so we'll use the diamond and the box. It'll be 4 times 4. When you have a leading coefficient greater than 1, we multiply that coefficient by the constant term. So we're looking for 2 numbers that multiply to make 16 that have a sum of 5. Let's see, to get 16, we have 1 times 16, those do not have a sum of 5. 2 times 8, those do not have a sum of 5. And 4 times 4, those do not have a sum of 5. So we cannot factor it anymore. And so we are done right here. So that means that this trinomial is not factorable. But we already did factor out the 2. Okay, let's reset just a little bit here and go back to a basic one. We looked at a lot of special cases. We look at this trinomial. We notice we can factor out a 3. So let's go ahead and divide each term by 3. 3v squared divided by 3 is v squared. 3v divided by 3 is equal to v. Negative 36 divided by 3 is equal to negative 12. We're wondering if we can factor this trinomial. So we're looking for 2 numbers that multiply to make negative 12 that have a sum of 1. Let's see, we need a positive sum. So we're thinking 3 times negative 4, because that has a product of negative 12 and a sum of negative 1. Let's switch that around here. Negative 3 times 4 does equal negative 12, and now they have a sum of positive 1, because the larger number is positive. So we've got 3 times v minus 3 times v plus 4. Here we factored completely. Hopefully these examples have been helpful. This is Mr. Ela signing off.